Beneath the tranquil blue of the open ocean lies a world of staggering violence and upheaval. A world where the ground itself can suddenly come alive, moving with a force and scale that dwarfs even the mightiest disasters on land. Far below the reach of sunlight, hidden from human eyes, the seafloor becomes a stage for some of the most colossal and mysterious events on Earth. Underwater avalanches, known to science as turbidity currents. These underwater landslides can travel for hundreds of miles, carrying billions of tons of sediment in their wake, silently redrawing the very map of the ocean floor. Imagine a force so immense that, in a single surge, it can bury entire cities beneath choking layers of mud, sand, and shattered rock. Picture a current moving faster than a speeding train, up to 60 miles per hour, racing down a submarine canyon. This is not the stuff of science fiction, but a hidden truth of our planet's last great wilderness. The scale of these events defies belief. A single underwater avalanche can transport more material in hours than all the rivers of the world do in a year. But what triggers these massive movements? The answer is as complex and mysterious as the deep sea itself. Sometimes the catalyst is clear. A violent earthquake shakes the seabed, or a volcanic eruption dislodges a mountain of sediment. Yet time and again, these avalanches occur with no obvious warning, no seismic tremor, no volcanic roar. The ocean simply shifts, and the world below is transformed. One of the most dramatic glimpses into this hidden realm came in 1929, off the coast of Newfoundland. A powerful earthquake struck the Grand Banks, but what followed was even more extraordinary. Deep beneath the waves, a vast section of the seabed gave way. In a matter of hours, a titanic flow of mud and sand thundered down the continental slope, racing across the abyssal plain. Along its path lay a series of transatlantic telegraph cables, lifelines of communication between continents. As the avalanche swept forward, it snapped these cables one by one, each break recorded precisely in time. By reconstructing the sequence, scientists realized the incredible truth. The avalanche had traveled for nearly 400 miles, moving at speeds that seemed impossible for such a massive, heavy flow. This event was not merely a catastrophe, it was a revelation. For the first time, researchers understood the true scale and speed of turbidity currents. Here was a process that could reshape entire landscapes, carving deep canyons and building towering underwater mountains. And yet, most of these events leave no surface trace, their power unleashed in darkness and silence. But the Grand Banks disaster is only one chapter in a much larger story, one that continues to unfold in the ocean's most shadowed corners. Around the world, deep-sea researchers are piecing together the clues left behind by these underwater avalanches. They study the strange, winding canyons that scar the continental slopes, geological scars left by countless ancient flows. They analyze the layers of sediment buried deep beneath the seafloor, each layer a silent record of a disaster that no human ever witnessed. What they have discovered is both awe-inspiring and deeply unsettling. Turbidity currents are not rare. They are a fundamental force in shaping the face of our planet. Some are triggered by the obvious: an earthquake, a collapse of a submarine volcano, or the sudden melting of icebergs at the end of an ice age. But others seem to occur spontaneously, perhaps set in motion by subtle shifts in water temperature, by the slow buildup of unstable sediment, or by forces researchers are only beginning to understand. These avalanches can travel incredible distances, up to 600 miles in a single surge, spanning entire ocean basins. Along the way, they can bury submarine cables, threaten vital communication lines, and even endanger undersea oil pipelines and other infrastructure upon which modern civilization depends. Yet because these disasters unfold in total darkness, in a realm where pressure would crush an unprotected human in seconds, we know only a fraction of their story. Cutting-edge technology is slowly peeling back the veil. Using deep-diving robotic vehicles, sonar mapping, and seafloor observatories, scientists are beginning to witness these events almost in real time. In some cases, sensors have captured the sudden rush of sediment-laden water racing down a canyon, churning up the seafloor and erasing everything in its path. The data reveal a process of staggering complexity, a churning flow that can shift from slow creep to explosive speed in moments, driven by physics as unique as the deep ocean environment itself. But for every event we record, countless others slip by unnoticed. The ocean keeps its secrets well. The signs are subtle, a sudden change in the composition of seafloor mud, a buried forest of ancient corals, or a broken cable lying twisted in the dark. Each is a clue, a fragment of a much larger puzzle. The consequences of these hidden avalanches are profound. They carve the submarine canyons that are among the largest geological features on Earth, many of which rival the Grand Canyon in depth and scale. They build the vast abyssal fans, underwater plains of sediment that stretch for thousands of square miles and provide crucial habitats for deep-sea life. They bury and preserve the remains of ancient organisms, locking away clues to Earth's past climate and evolution. And at times, they may even trigger tsunamis, sending waves racing toward distant shores with little warning. Beneath the surface, the ocean is in constant motion, a world where mountains collapse in silence and valleys are born in darkness. The study of turbidity currents is a frontier science, challenging our understanding of geology, hydrodynamics, and the interconnectedness of life on Earth. Every new discovery hints at forces we barely comprehend, energies unleashed on a scale that is almost unimaginable. The true mystery, however, lies in the unknown. Why do some submarine slopes remain stable for millennia, while others collapse with no apparent cause? What subtle signals, whispered through the rock, the water, the shifting sands, foreshadow the next great avalanche? Could events of even greater magnitude be waiting to unfold, unseen, in the ocean's deepest trenches? In exploring these questions, we confront the profound humility of our place on Earth. For all our technology, for all our ambition, the deep ocean remains a realm beyond our control, a domain where the most powerful events unfold without witness or warning. Here, in the last wild places of our planet, nature writes its own stories, indifferent to the presence of humankind. As we continue to probe the mysteries of the deep, one truth becomes ever clearer. The ocean is not merely a passive backdrop to life on Earth, but an active, restless force. Its avalanches, though invisible to most, shape the destiny of continents, the fate of species, and the very future of our civilization. In the shadows of the abyss, the story of our planet is still being written, one massive, mysterious event at a time. And so, the next time you look out over the calm surface of the sea, remember, beneath that serene expanse lies a world of unstoppable movement, where the ground itself can suddenly surge and race for hundreds of miles, in darkness deeper than night. The ocean keeps its secrets well, but with every discovery, we come one step closer to understanding the impossible truths of Earth's last true wilderness.